According to the National Fire Protection Association 70 standard, specifically Article 130.5 ATWR, the requirement for ground fault protection equipment, often abbreviated as GFPE, is determined by the presence of a 1000 amp or larger service entrance or feeder disconnect on an industrial or commercial premises. This requirement is triggered when the disconnect is not within sight of the location where the disconnecting means for that electrical equipment is situated. In such cases, a ground fault protection system is mandated and must be designed in accordance with Section 250.33c of the National Electrical Code. Applying this to your specific situation, if your switchboard, which utilizes the 6-handle rule, is not within sight of the location where the disconnecting means for the electrical equipment is located, then you are indeed required to install a ground fault protection system on the breaker that is serving the 1000 amp or over 480/277 volts, 3-phase distribution panel. The key factor here is the visibility of the disconnect, not whether the switchboard serves as a main or a sub-panel. The ground fault protection is implemented to provide a layer of safety against ground faults, which can pose significant electrical hazards. The 6-handle rule, as it's commonly known, pertains to the number of overcurrent devices that can serve as a service disconnecting means. The National Electrical Code permits up to 6 switches or circuit breakers to serve as the disconnecting means for a service. This rule is relevant to the overall design and configuration of the electrical system, but it doesn't supersede the ground fault protection requirements outlined in Article 130.5 ATWO and 250.33c. The purpose of ground fault protection is to detect ground faults, which occur when current unintentionally flows to ground through a path other than the intended grounding conductor. These faults can be caused by insulation failure, damaged wiring, or other factors. Ground faults can result in dangerous touch voltages, equipment damage, and even fires. Ground fault protection systems are designed to quickly detect and interrupt these faults, minimizing the risk of harm. The requirements in Section 250.33c further specify the design and installation criteria for ground fault protection systems. These criteria include the setting of the ground fault protection device, which determines the level of ground fault current that will trigger the device to trip. The setting must be coordinated with the overall system protection to ensure that the device operates properly and does not cause nuisance tripping. Additionally, the grounding electrode system must be properly installed and maintained to provide a low impedance path for ground fault current to flow back to the source. This helps to ensure that the ground fault protection system can effectively detect and interrupt ground faults. The installation of ground fault protection typically involves the use of a ground fault sensor, which is a device that monitors the current flowing in the circuit. When a ground fault occurs, the sensor detects an imbalance in the current and sends a signal to a tripping device, such as a circuit breaker. The tripping device then opens the circuit, interrupting the flow of current and preventing further damage or injury. It's important to note that ground fault protection is not a substitute for proper grounding. Grounding is essential for providing a safe path for fault current to flow back to the source, which helps to prevent dangerous touch voltages. Ground fault protection is an additional layer of safety that is designed to detect and interrupt ground faults that may not be effectively cleared by the grounding system alone. In summary, the requirement for ground fault protection in the scenario is primarily based on the size of the service entrance or feeder disconnect and the visibility of the disconnecting means. If the disconnect is 1000 amps or larger and is not within sight of the disconnecting means for the electrical equipment, then ground fault protection is required, regardless of whether the switchboard is a main or a sub-panel. This requirement is outlined in National Fire Protection Association 70 Article 130.5 ATWR and Section 250.33c of the National Electrical Code. This is regardless of whether the switchboard is a main or a sub-panel. The visibility of the disconnect is a critical factor in determining the need for ground fault protection. When the disconnect is not within sight, it can be difficult for personnel to quickly energize the equipment in the event of a ground fault. This can increase the risk of electrical shock or other hazards. Ground fault protection provides a means of automatically detecting and interrupting ground faults, even when the disconnect is not readily accessible. The 480/277 volt three-phase system is a common voltage level used in commercial and industrial applications. This voltage level is often used to power large motors, lighting systems, and other equipment. Because of the high voltage and current levels involved, it is important to provide adequate protection against ground faults. The 1000 amp threshold for ground fault protection is based on the potential for high ground fault currents to flow in larger systems. These high currents can cause significant damage to equipment and pose a serious risk to personnel. Ground fault protection is designed to limit the magnitude and duration of these currents, reducing the risk of harm. It is important to consult the National Electrical Code and other applicable standards for specific requirements related to ground fault protection. These standards provide detailed guidance on the design, installation, and testing of ground fault protection systems. It is also important to ensure that ground fault protection systems are properly maintained and tested on a regular basis to ensure that they are functioning properly. Ground fault protection is just one aspect of overall electrical safety. It is important to implement a comprehensive electrical safety program that includes proper grounding, overcurrent protection, and other safety measures. A well-designed and maintained electrical system can help to minimize the risk of electrical hazards and protect personnel and equipment. Also, the selection of the ground fault protection equipment must adhere to standards such as Underwriters Laboratories 1053, which covers ground fault sensing and relaying equipment. This standard ensures the reliability and performance of the equipment under various conditions. Furthermore, coordination studies are crucial for determining the appropriate settings for the ground fault protection devices. These studies analyze the electrical system's characteristics to ensure that the ground fault protection operates effectively without causing nuisance tripping. The goal is to have the ground fault protection trip only when a true ground fault occurs, minimizing disruptions to the electrical system. Periodic testing and maintenance of ground fault protection systems are essential for their continued reliability. Testing should be performed in accordance with manufacturers' recommendations and relevant standards such as the National Electrical Testing Association standards. Maintenance activity should include visual inspections, cleaning, and verification of proper operation. Proper documentation of testing and maintenance activities is also important for tracking the performance of the ground fault protection system over time. This documentation can be helpful in identifying potential problems and ensuring that the system is operating as intended. In addition to the technical aspects of ground fault protection, it is also important to consider the human factors. Electrical safety training should be provided to all personnel who work on or near electrical equipment. This training should cover the hazards of electricity, the importance of ground fault protection, and the proper procedures for working safely with electrical equipment. Personnel should also be trained to recognize the signs of a ground fault, such as unusual noises, smells, or equipment malfunctions. By combining technical expertise with a strong focus on human factors, it is possible to create a safe and reliable electrical system that protects personnel and equipment from the hazards of ground faults. In Illinois, the adoption and enforcement of the National Electrical Code is managed at the state and local levels. It is important to consult with local authorities to determine the specific requirements that apply in your area. These requirements may vary depending on the type of occupancy, the size of the electrical system, and other factors. Furthermore, the type of ground fault protection required may vary depending on the specific application. For example, some applications may require ground fault protection for equipment, while others may require ground fault protection for personnel. It is important to carefully consider the specific requirements of your application when selecting and installing ground fault protection equipment. Lastly, remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements to ensure that your electrical system is safe and compliant. Consulting with qualified electrical engineers and contractors can help you to navigate the complexities of electrical codes and standards and ensure that your electrical system is properly designed, installed, and maintained. In the scenario described, where the switchboard utilizes the 6-handle rule and is serving a 1000 amp over 480/277 volts Three-phase distribution panel. The need for ground fault protection equipment is primarily dictated by whether the switchboard is within sight of the location where the disconnecting means for the electrical equipment is located. If the switchboard is not within sight, then ground fault protection equipment is required, regardless of whether the switchboard is a main or a sub-panel. This is a critical safety requirement outlined in National Fire Protection Association 70E and National Electrical Code.